Hello everyone, welcome back. We're going to do another telescoping series question. And so in the very first example, our function looks very similar to this one where we have some function minus another function. And so I told you guys that that's really a good indicator of the fact that this is probably a telescoping series. I'll write that up for us for a second. But there are times where it's not always going to be in the form where we have a fraction minus a fraction. And so we're given this function 1 over n plus 2 n minus n plus 3. And so one of the things that we learned in BC Calculus is partial decomposition. So we can actually say the series is actually going to be equal to a over n plus 2 plus b over n plus 3. And so using partial decomposition, we can actually figure out what the a value and the b value is. And usually one of these numbers will actually be negative, which would then get us in the form where we have a function minus another function. And so when you actually do partial decomposition, you're going to get that a is actually equal to 1 and that b is equal to negative 1. So let's go ahead and rewrite this series with our partial decomposition. So here we go with this. And so these two series, they're actually equal to each other, because if you were to actually subtract these fractions, you would actually get this back. Now what we can do is actually use the telescoping series. Now what we can do is use the fact that we have this function and use telescoping series to find the sum and see that it converges. So just like in the previous example, we're going to set n equal to 1 and we're going to find out what our terms are first. And so we get 1 over 3 minus, and this is going to be 1 over 4. So I just replaced n with 1 and got my function. So again, just like before, do not simplify. We don't care about that. And so we're going to go ahead and put n equals 2, and we're going to get, well, n equals 2 is going to be positive 1/4, and then we're going to subtract from that 1/5, and then our last one, because after a couple of these, you can kind of see what's going to happen with this. So if I plug in 3, I'm going to get 1/5 here, and I'm going to subtract 1 over 6. So I don't really need to go any further with this, because hopefully you guys see a pattern here that whatever this term is here, the previous term, it's going to be the positive value of that. So again, if you were to put in equals 4, I would get 1 over 6, and that would be a positive 1 over 6, so the 1/6 would actually cancel out. You can clearly see that the 1/4 cancel out, the 1/5 cancel out, and I can do this in an indefinite amount of time. So we're going to see that the actual answer to this problem, the sum actually to this problem, is 1/3, and that we can also say that this series is going to converge. All right, so let's look at the next example and see what we can do about that. Okay, so since in this example we're already in the one function minus another function, we can go ahead and just start listing our terms out here and see what's going to happen with this. And so if we put in k for this, we're going to get 3 over 2 squared, which is 3/4, and then we're going to do minus 3 over 1. So our first term here for k equaling 1 is going to be 3/4 minus 3. And so then we're going to add to this when k is equal to 2, and we're going to get 3 over 3 squared, so 1/3, or let's just leave it 3 over 9, 3/9, minus 3 over 4. And then if we were to go to the k equals third term, we're going to go ahead and do plus, and so we're going to do 3 over 4 squared, 16, and we're going to subtract 3 over 9. And just like in the previous example, right now hopefully we can see what a pattern's coming up with here. So this 3/4 here is going to cancel out with this 3/4 here. This positive 3/9 here is going to cancel with this negative 3/9 here. And as we move through here, we will get a negative 3 over 16. So they're going to cancel out too. So as we can see, the sum of this series is actually going to be equal to -3. And I like this example because a lot of students think that for telescoping series that the first term is always going to be part of the solution, and you can see that clearly the first term got the first term got eliminated, and so now we're left with this -3. So just like the previous two examples, this is also a series that's going to converge. I may add another video soon that shows you a telescoping series that will actually diverge, because there are some that do that. But right now, two very simple examples of the telescoping series and how they converge, and then also how we were able to find the sums. So, and normally for BC Calc, the pattern becomes pretty evident, within the first 3, 4, 5 terms. So I hope that helps, and I'll see you guys next time.